The humpback whale is almost certainly one of the most intelligent animals in the world. Once humpbacks populated every ocean and sang their songs through all four quadrants of the sea. Today, because of man's greed, the song of the humpback may not echo for much longer throughout the vastness of the ocean. Less than 100 years ago, the humpback whale sported and spouted in all the oceans of the world. It's a slow-moving whale that tends to keep close inshore, an easy target for the whaling industry. By 1966, when the humpbacks were given protection, the harpooners had shot the world population down to only 4,000 animals. Despite protection, the humpback still ranks as an endangered species and may yet become extinct. Today, there are only isolated populations of humpbacks left, and they're largely in the Pacific. One of the main concentrations arrives annually off the principal islands of the Hawaiian chain. In November, the first humpbacks appear off the islands of Molokai, Lanai, and Maui. It's thought they come here to calve and mate. The population builds up slowly to about 400. The whales congregate in the sheltered waters off the old whaling town of Lahaina. In the 1850s, Lahaina roadstead would have been forested with the masts of whaling ships that ranged as far north as the Bering Sea and as far south as the Antarctic ice. This quite insignificant Hawaiian settlement became the wild and sinful whaling capital of the Pacific, a sort of Dodge City by the sea. Today, the whales are again the center of Lahaina's prosperity, but in a quite different way. Lahaina has become a mecca for the increasing numbers of people who care about whales and the threat to their continued existence. Everything in the town has once more become whale-oriented. Thousands of visitors arrive each year to observe or just to catch a glimpse of the humpbacks offshore. This old whaling brig being restored as a museum is a reminder of the bad old days. The flag flying at her stern is, given international good management and goodwill, an emblem of the better days that may come. Today, a new kind of whaling ship patrols the waters off Lahaina. The Easy Rider carries members of a scientific research project along with our camera crew. From the moment she began to patrol Lahaina Sound in search of humpbacks, she enjoyed an escort of their smaller relatives, the Pacific bottlenose dolphins. Aboard her were the world's leading experts on the songs of the humpback whale, Katie Payne and her husband Roger. The Paynes have been studying the singing whale for years, mainly off Bermuda. Most of the Paynes' research has been done by surface observation and underwater recordings. Now, with a crack underwater camera team, at last they had the opportunity, literally, to probe deeper. The team was headed by Al Giddings, one of the world's most expert divers and underwater cameramen. The second underwater camera was handled by veteran Chuck Nicklin. Dr. Sylvia Earle, accomplished scuba diver and leading American woman marine biologist, completed the scientific party. The trouble about a whale is that it's like an iceberg. Most of it lies beneath the surface. The advantage of Lahaina Sound as a study area was that the water is so beautifully clear. For the first time, the scientists would be able to dive and swim with the great animals to study their behavior, while the camera team recorded it on film. To observe the whale as no scientist had seen it before was the first objective of the expedition. The second was to learn more about how and why the humpback whale sings its mysterious song. So now, an underwater microphone snakes downward to record one of the world's most uncanny and emotive sounds. The song of the humpback whale is immensely powerful. The entire song can travel up to 5 miles underwater, and the deep bass notes can be heard 50 miles away. Amazingly, the whales sing their songs without benefit of vocal cords, simply by moving masses of air within their bodies. It's like singing an operatic aria while holding your breath. As Sylvia Earle and Peter Tyack, Roger Payne's research assistant, were soon to learn, when a humpback sings, it lies almost motionless in the water. That means that these two whales beneath their boat are not the singers they're recording. They're far too active. The song comes from somewhere far in the background. The waters off Lahaina are particularly clear, without the clouds of plankton on which the whales feed. So the question arises, what do these 40-ton giants feed on when they come to Hawaii? The amazing answer is, they don't seem to feed on anything. As far as anyone can tell, they go without any food whatsoever for a period of 4 or 5 months. The whales proved very approachable on the surface, but underwater turned out to be a different matter. At first, the team used big air tanks because they gave the best diving capability. But large air tanks produce a good deal of underwater noise, as well as a long stream of bubbles when the diver exhales. Though some remarkable scenes were obtained, like this shot of a pregnant female, the whales tended to fade away, even beyond the 300 feet camera range that was possible in the clear water. Normally, whales only blow at the surface. Sometimes the humpbacks produced underwater bubbles, usually when crowded by another whale. But the divers wondered whether their own bubbles weren't contributing to a stress situation. And the last thing they wanted to do was to disturb the whale's serene underwater world. This shot gives an idea of a whale's size. Diver Sylvia Earle weighs 104 pounds. The whale is closer to 80,000 pounds. The whales were utterly peaceful, even lifting their giant flippers carefully to avoid striking the divers. Sylvia Earle once lived for 2 weeks on the seabed in a pressurized home with 5 other aquanauts. Swimming with the whale, she said, surpassed anything she'd ever experienced in a long underwater career. Often she felt the whales were watching her. At times they appeared intensely curious. This is a well-grown calf playing just above its mother. The whale's song haunted them every time they dived. Sometimes it was an almost unbearable physical assault of sound and pressure, not only on the eardrums but on their entire bodies. The sensation is similar to standing near the deep bass pipes of a cathedral organ. Both Roger and Katie Payne are convinced that breaking the code of the humpback song will prove an important step towards understanding the animal's undoubted intelligence. The team decided to try a somewhat light-hearted experiment in Lahaina Sound. An underwater speaker was lowered to play back the whale songs they had already recorded. They maneuvered the rubber boats close to whales on the surface. Then Chuck Nicklin and Sylvia Earle went down to see what happened when the whales heard a mechanical reproduction of their own song. Would they react in any way? The whales weren't scared by the playback. On the other hand, they weren't attracted either. Perhaps the best description is that they were indifferent. No one was really surprised. There was no way that such a tiny speaker could reproduce the booming low tones of the whale song. Fortunately, the pained study of the song at the surface was proving more fruitful. Based on a study of 20 years of recording, Katie and Roger had carefully started to unravel the subtle and complicated rules of whale song composition. For example, they discovered that the humpbacks of Hawaii sang a quite different song from the humpbacks of Bermuda, although obeying the same general musical rules. Throughout each singing season, all whales in a given population sing the same song, but the singers are constantly altering that song. At the end of the singing season, they go off to feed and do not sing a note for months on end. But when they start singing once again, they pick up precisely where they left off many months before. In other words, humpbacks have phenomenal memories. For some time past, Katie had been patiently comparing the songs of different years and unraveling the clues that give rise to this theory. Roger transcribes the song just as if writing down music, which in a way he is. Although each whale sings its own version of this year's hit song, and the song changes gradually, each singer uses the same overall structure. Katie uses a poetic comparison to describe the phenomenon. She says it is as if all the whales agree this year to use the sonnet form. Next year, the form may be different. The colored bands on Katie's charts reflect the different themes sung year by year. Note that there is some overlap, which obviously reflects an overlap in population. This is the spectrograph, a recording electronically portrayed of a quartet of whales. And here are the individual voices of that quartet. each singer apparently totally oblivious and ignoring the other three. What's important to note is that each whale is singing precisely the same song. It's a bit like a barbershop quartet singing Sweet Adeline in 4 different keys and tempos. Why the humpback sings its song is still something even the Paines can't fully answer. But they are now almost certain the song is part of a breeding ritual sung only by the males. It also seems likely that the deep and repetitive sounds are used for communication over long distances. The underwater team was still looking for a better way to approach whales without disturbing them. So they loaded their rebreather apparatus with a chemical that takes the carbon dioxide out of the air a diver exhales. A rebreather recycles the air so that a diver breathes on a closed circuit, making no noise underwater and leaving only a small trail of bubbles behind him. The whales certainly seem to appreciate the diver's courtesy and allowed them to approach really close. With one whale, they were close enough to film the barnacles on the leading edge of the flipper. The barnacles, a species which only attach themselves to whales, drop off in the warm water of Hawaii. But there is one serious snag to a rebreathing apparatus. A diver using such a device can only safely descend to 30 feet. Below that, he can quickly become dangerously ill. As long as the whales obliged by swimming near the surface like this, the rebreather paid off. The rebreathers produced one of the finest records of all, that of a very pregnant female passing close to camera. Often, though, the whale suddenly decided to dive deeply. On one occasion, Chuck Nicklin followed them down to 60 feet in the excitement of filming, fortunately without serious results. Using rebreathers, they obtained another fine shot of underwater bubbling. Results had been good, but the need to keep to the 30-foot level was proving too limiting. The diving team had one further technique to try out. The divers had found that the whales were most approachable when the team snorkeled at the surface. Now, they combined the snorkeling approach with the use of small air tanks that make far fewer bubbles. One of the earliest successes was this close-up of a very old veteran, covered with barnacle marks and body scars. It may be anything up to 50 years old. Humpbacks probably live as long as we do. If so, it's a very lucky whale, possibly one of the oldest of its kind. The big humpbacks are the ones the harpooners usually seek out first. Most of this one's life would have been lived long before humpbacks were given protection. And even today, they're not entirely safe. Some whaling nations still refuse to honor the ban on humpbacks. It's even possible that's a harpoon scar on its dorsal fin. When whales were spotted by snorkeling at the surface, it proved quite easy when using the small tanks to dive without alarming them. In this way, they obtained some remarkable group portraits, like this one of a mother with small baby swimming with two other adults in close attendance. Like all mammal mothers, humpbacks nurse their babies, and a young calf may grow as much as 100 pounds a day. Remarkably, the mother provides all the nourishment for this growth, even though she's not feeding at all, and will not feed for months to come. While they stealthily stalked the whales, the divers were sometimes stalked by a far more sinister hunter. A big white-tipped shark with a pilotfish seemingly glued to the end of his snout. Sylvia Earle finally sends him about his business. She confessed it had been a bad moment, but added, for the shark. Never once did the diving team feel themselves in any danger from the 40-ton giants. Gentleness was in the humpback's every movement. Gentleness, too, was obvious in the relationship between mother and baby. The little whale touching his mother frequently with his flippers and sometimes appearing almost to hold on to her. Humpbacks are highly social animals, and even adults communicate by touching each other. The team had finally found the best diving technique for winning the whale's confidence. This whale swam so close that Al Giddings was knocked back 10 feet by the wash of its tail flukes. There were so many questions that remained unanswered. For instance, who was the third whale who often accompanied mother and child? Was it perhaps the father, or a suitor, or a helpful female, or perhaps an older calf? The third whale again, from a different viewpoint. Note the two dolphins riding on the mother's bow wave and turning away to her port side. So many mysteries of the singing whale had yet to be solved. And yet in the clear waters of Hawaii, some of these mysteries had for the first time been glimpsed, even if not fully understood. Now it was time for the expedition to follow the whales to the icy waters of Alaska, where even more remarkable discoveries were to be successfully recorded. year, starting in late March, the humpbacks leave Hawaii. When they next near land, they are thousands of miles away in the North Pacific. They have not eaten for months. Now they must replenish their enormous bodies. As they break their fast, there is another change in behavior. Their mysterious whale song stops. They do not sing on their feeding grounds and will not until they return to Hawaii. They travel slowly at 4 or 5 knots, arching the humpback, after which they are named in a dignified curve. The shape of the back, as well as the slender tail flukes, identify the traveler quite clearly as a humpback whale. Their progress here has been filmed in slow motion, but there's nothing slow about that telltale blow. To change the entire contents of its huge lungs, which it does in 3 or 4 seconds, the air leaves the blowhole at speeds of up to 300 miles per hour. This much is known about the humpback as it travels the oceans. What is still a mystery is where precisely the few remaining breeding populations go. The humpbacks of Hawaii, for instance. This was another one of the problems our expedition hoped to solve. As in years past, the 400 humpbacks who have spent 4 months off Hawaii leave and migrate north. Some are thought to go as far as the Bering Sea. Others frequent the sheltered inland waters off southeast Alaska. Each year, about 20 animals enter the remarkable 50-mile-long inlet called Glacier Bay. It seems likely that some, maybe all of these, have traveled north from Hawaii. Glacier Bay is a beautiful, weird, cold place. The water in it is, not surprisingly, brackish rather than salt. The bay is fed by 12 huge rivers, rivers of ice that flow out of the seemingly endless Alaskan peaks. Those glaciers dump their ice directly into the sea, a process known as calving. With its waters littered with bergs, Glacier Bay looks like a hostile place. But in the short Alaskan spring and summer, which reaches its peak around July the 4th, wildlife finds it quite the opposite. Harbor seals come here to bed their pups on the ice. For water birds, Glacier Bay supplies ideal breeding grounds. Bald eagles nest here. There's seclusion for them and plenty of food. That fierce pirate, the glaucous winged gull, nests here in numbers. When the nesting birds arrive, it's a sure sign that the humpbacks are not far behind, because both birds and whales come here for the same reason. Gulls, guillemots, tufted puffins, and thousands of phalaropes. They spotted that the shrimp-like creatures called krill are in the bay. Krill is what the humpbacks feed on. About the same time, another annual visitor arrives. It's a boat called the Ginger. She's manned by the Geraz family. This trip, she also carries Dr. Sylvia Earle, recently arrived from Hawaii. Chuck Geraz is a marine biologist and schoolteacher from Alaska's capital, Juneau. With his family and selected research graduates, he spends the whole summer studying the humpbacks of Glacier Bay. Chuck's daughter, Sue, age 14, spots one of the first of the season. Chuck first became involved when he used to fish for crabs in these waters on summer vacations. Then he began to study the glaciers in the bay and their effect on the ecology. From that, it was a short step to studying the most dramatic part of that ecology, the whales. The whole Duras family is as dedicated to whale research as is Chuck himself. Their work, shared by the underwater team from Hawaii this year, has many objectives. One is to try to discover by close observation of individual markings whether any of the humpbacks here in Glacier Bay come from Hawaii. You'd think this was a pretty distinctive face, but all humpbacks look like they've got rivets in their top jaw. The scientists look for distinctive markings on tail flukes and flippers. When the whales first arrive in the cold waters of the bay, the temperature there ranges between 38 and 54 degrees Fahrenheit. They're extremely active. Probably they're simply reacting to new neighbors and to new surroundings. It's difficult not to think of their activities as playfulness. Here, a pair of feeding humpbacks accidentally roll over an iceberg weighing several hundred tons. Some of their more violent reactions most certainly aren't play. To establish the reason for these has a high priority in Chuck Duraz's work. Each summer, more and more cruise ships visit Glacier Bay. 8 years ago, there were 20 ships a season. Today, there are 300 to 400. Often when a ship passes, the whales display violently in its wake. Glacier Bay comes under the U.S. National Park Service. The park's authorities are naturally anxious about the effect boat pressure may be having on the whales. Is this awesome flippering a territorial reaction to the cruise liners? Duras feels that the humpbacks may be feeling pressure from the big ships. He points out that this year there are definitely fewer whales in the bay than last year. He's trying to find out if he's right. If the answer is yes, then future boat traffic may have to be limited if the whales are not eventually to disappear. In his own approaches to whales, Chuck could not be more cautious. He feels that, large as it is, the bay can only support so many whales. He sees all large floating visitors as blubber whales, fiberglass whales or steel whales. Here he approaches 2 dozing blubber whales and a fiberglass whale without causing them to do more than turn over in their sleep. But a passing steel whale has a more drastic effect. The propeller beat of the liner probably caused the sleepers to wake up and, as it were, pull the blankets over their heads. No one wishes to deny visitors the joy of seeing whales. Whales need all the public support they can get, but some limitations on boat traffic may have to be imposed. Often a humpback will breach, leap clean out of the water, apparently in disapproval after a ship passes. Other manifestations include lobtailing, lashing the water with tail flukes. But it will take a lot more study before anyone can be sure whether these displays are caused by boat traffic or whether they're simply reactions to other whales nearby. One of the facts that Roger Payne had established the previous year when working with Chuck Duras was that the whales do not sing on their feeding grounds in Glacier Bay. But they do have a limited social vocabulary, which an underwater mic records, while the surface microphone captures the often deafening noise of the whales blowing. The social sounds are the low-pitched grunts and whistles. In midsummer, daylight in Glacier Bay lasts 18 hours. And as a result of the extra sunlight, the amount of vegetable plankton blossoms, and the population of krill that eat the plankton explodes. Much of Sylvia Earle's work with Chuck Duras has concerned this food source. Krill are surprisingly difficult to capture in any numbers. Despite their size, they're fast swimmers and avoid capture only too easily, except when pursued by a whale. It's incredible that a 40-ton creature can sustain itself on such insignificant prey. In fact, the humpbacks are one of the most efficient converters of solar energy into flesh and bone. They're at the top of such a short food chain. Sun produces vegetable plankton. Krill eat plankton, and whales eat krill. They eat an awful lot of krill. In Glacier Bay, individuals often feed for 18 hours without stopping. Trips in the Zodiac gave Sylvia Earle an excellent opportunity of trying to identify whales she'd met underwater a few months before in Hawaii. Unfortunately, this year there seemed to be no old friends present. But then there were only 20 whales in the bay and 400 off Hawaii. She holds out a salinity gauge to catch some of the water from a whale's blow. The vapor in a whale's spout is thought to be caused by external water lying round the blowhole. The salinometer will show whether any portion of these droplets came from inside the whale. The scientists caught most of the spray. For the moment, the experiment was inconclusive. That's a whale feeding on krill right beside the boat. Shortly, we'll see exactly how the whale manages so successfully to scoop up the elusive krill. At every encounter, personal characteristics of each whale are logged. Tail prints are often as distinctive as fingerprints. For identification purposes, every whale in the bay is given a name. That was White Eyes. Everyone aboard the Ginger has a routine. Jenny, Chuck's wife, navigates and is at the wheel most of the time they're observing whales. Since the Ginger is her only home, she runs it like one. On many days, the observers, both family and research students, are on deck recording whale behavior for 12 hours or more. Sarah Hinckley, graduate student from the College of the Atlantic, maps the Ginger's path and that of the whale under observation. The plot for this day, the 8th of July, records every time the animal surfaced. From such painstaking detail will come facts that will help the national parks decide which parts of the bay are crucial to whales and may therefore need protection. At 14, Chuck's daughter Susie is a veteran whale watcher. Her whale log complements the charts made by Sarah Hinckley. Another student works on breathing rates. The graph is a breath print of a humpback. When a humpback is excited, its breathing speeds up like our own. Comparison with the log shows what the cause may have been. As a doctor might recognize a patient by his heartbeat, so individual humpbacks are recognizable by their breathing graphs. So each member of the crew has an area of study which he or she will work on, fair weather or foul, every day, up to 18 hours a day for at least 2 months. Their reward is that they are discovering more than has ever been known before about the behavior of one of the world's largest and most mysterious creatures. A creature that may soon disappear from the face of the earth. The waters of Glacier Bay are not clear enough for underwater photography, but being enclosed, they are usually smooth, except when a 10-ton youngster named Garth decides to breach in the observation area. This surface calm makes the bay ideal for observing the humpback's feeding behavior. The bubbles in the foreground made by Garth's mother Gertrude are part of that fascinating feeding technique, as we'll see shortly. That's a humpback feeding on krill. This technique has been christened lunge feeding. The whale detects a concentration of krill and then lunges through it with its mouth open. Sometimes a pair of whales lunge feed together. The white stripe on the right-hand whale is its tongue. Either side are the baleen plates, or whalebone, which filter out the krill. Often the whale lunges on its side or even its back, so that the weight of its enormous bottom jaw and the water it has scooped up helps close the mouth. There are all sorts of variants on this method of feeding, most of them unimaginably weird to watch. In this spectacular sideways lunge, watch the pleats under the whale's lower jaw open up as hundreds of gallons of water and krill are scooped up. Those pleats, so slick and streamlined normally, ripple like treads on a collapsing tire. possible that the whale's tongue plays a large part in squeezing the krill against the baleen filter plates. The small white spots are the barnacles which the humpbacks pick up in these northern waters and shed when they go south. Hanging below like seaweed are another species, goose barnacles. The second technique the humpbacks use is called flick feeding. The tail is flick forward, throwing the krill towards that open scoop of a mouth. Again, it only works where krill are particularly concentrated. The tail movement is quite different from the one used when shallow diving like this. There's the flick again. But the most surprising discovery by Chuck Duraz in Glacier Bay concerns the third feeding method. This was first reported off Greenland in 1928, but no one believed it. Now Chuck has unraveled its mysteries. It starts with a circle of bubbles. And ends with the whale surfacing nearly vertically with mouth open in the middle of the bubble ring. As it closes its mouth, watch the water being squeezed out, leaving the krill caught by the baleen plates. The really amazing thing is how the whale corrals the krill inside the bubble net. It was Roger Payne who, the previous year, discovered the finer points of bubble netting. The whale swims round in a tight circle but spiraling upwards, so that the last bubbles it blows reach the surface at much the same time as the first ones. The bubble net forces the krill to concentrate at the center where the whale scoops them up. Roger also discovered how the amazing steam engine sound the whale makes as it blows the bubbles seems to concentrate the krill. Just occasionally the whale gets it all wrong. Perhaps the net isn't to its satisfaction, or maybe the krill isn't dense enough. Whatever the reason, it decides not to feed and comes up horizontally instead of in a vertical feeding position. It makes a shallow dive to try again, often almost immediately. Its top jaw looks like a ship's hatch as it slams down on the krill soup. Every scientist who has studied the humpback is aware of the highly intriguing fact. The humpback whale has a brain over 5 times the size of a man's. Equally important, that brain is formed much along the same lines as our own. It is a highly sophisticated, possibly intellectual brain. With this in mind, can we dare let the last, pitifully few numbers of this wonderful species sink from sight? There is a poignant and improbable postscript to the saga of the singing whale. Not long ago, spaceship Voyager was launched on a journey designed to last thousands of years. One of its functions is to carry Earth sounds to the stars. And one of those Earth sounds is the song of the humpback whale. As it passes the planet Jupiter 2 years after liftoff, Voyager will be hurled out of our solar system and into the stellar void, taking the whale song with it. President Carter described Voyager as a message in a bottle cast on the oceans of space. Such messages are usually cries for help. Alas, help in this case may come too late. It seems sadly typical of modern man that he should be clever enough to put the song up there among the stars, but insensitive enough to obliterate the singer here upon his own planet.